Okay, let's tackle this problem right here. It says, what volume of a 0.305 silver nitrate solution is required to react exactly with 155 milliliters of a 0.274 molar sodium sulfate solution? Okay, so first thing we know is this is a reaction, but what kind of reaction is it? Is this even going to react? So let's go ahead and write down that reaction. We know that we are starting off with silver. So I have silver nitrate plus I have Na2SO4, a sodium sulfate solution. These are going to both be aqueous. This is aqueous. Those are going to form ions when I put them into solution. And when I combine those, then what's going to happen? Well, when I do these kinds of reactions, again, the way I think of it is a little dance. These guys come together at the dance, and these guys come together at the dance, and they go home with different partners. So the silver, which is a cation, is going to end up going with the anion sulfate, and the sodium is going to end up going with the nitrate. So it's a double displacement reaction. So the products are going to be here silver sulfate. I know it's an Ag2 because silver always forms a +1 and sulfate is a -2, and that is also then going to give me sodium nitrate. Okay, let's go ahead and balance this up. I need to put 2 silvers right there. I need to put 2 sodiums right there, and I think that should get me to where I need to be. You can look at that a little more closer to see if it balances, but it does. So now let's figure out what type of products these are going to be. And I have to do this, I have to look at my solubility table since this is happening in solution. And so I have silver sulfate and I have sodium nitrate. So I do have a solubility table right here. And I already know that anything with a sodium in it is going to be soluble. And then I also have that sulfate, that anything with a sulfate in it is going to be soluble except when it is with strontium, barium, lead, or silver, and we know that we have silver sulfate. So this is actually going to be a solid. It is insoluble in solution. So when I come back here to my problem, I note that that is a solid, and this is going to be aqueous. So here's my equation right here. And so I can focus on the math right now. Now what I like to do, whenever I see those big M's, those big molars, and I have to do some math with them, unless it's a dilution problem, I always write down what the big M really means. And so this is going to be 0.305 moles per liter of silver nitrate. I'm going to just say my molarity is moles per liter, and I get that from right here. And so I can use this now as a conversion factor. I'm going to do the same thing for the sodium sulfate right here. That really means in my mind that there are 0.274 moles of sodium sulfate for every liter. Now I have a couple of conversion factors. One of the problems of these, when you see these, where the heck do you start? Well, what I always do, and because I've done so many of these, is whenever I see a volume of a concentration, this 0.274 molar, I know that that's right where I'm going to start 90% of the time. And so I'm going to write down I have 155 milliliters of that sodium sulfate, Na2SO4 solution. And I never deal in milliliters when I'm dealing with molarity, so I know that there are 1,000 milliliters in 1 liter of sodium sulfate. Now I can use this conversion factor that I wrote down right here. Okay, so I know that in 1 liter of sodium sulfate that there are 0.305 moles of sodium sulfate. Okay, and now I can use my stoichiometry that I figured out that for every 1 mole of sodium sulfate, I am going to consume 2 moles of the silver nitrate. So I know that for every 1 mole of Na2SO4, I'm going to consume 2 moles of the silver nitrate. That's my stoichiometry. When I do reactions, I have to use that stoichiometry. And now I'm asking for a volume, so I can use this conversion factor right here that I already wrote down ahead of time. I'm just going to flip it over and say that there are 0.305 moles of silver nitrate in every liter of silver nitrate. Okay, I'm going to just go back and check that all of my units cancel. So milliliters are going to cancel, liters of sodium sulfate are going to cancel, moles of sodium sulfate are going to cancel, moles of silver nitrate are going to cancel, and I'm left then with liters of silver nitrate. Okay, and I'm going to just go ahead and put that into my calculator. So I have 155 divided by 1,000 times 0.305 times 2 divided by 0.305, and what I'm left with when I do all that is I'm left with 0.278 liters. It's going to be 3 sig figs, and if I want I can convert that back to milliliters, where I have 278 milliliters. So that's how you tackle this problem, is understanding that there is a reaction, writing out that reaction, understanding that it is going to be a precipitation reaction, understanding that even though that wasn't 100% crucial for this particular problem, then using these molarities as conversion factors, and then go ahead and writing out our problem here, understanding that I have this stoichiometry that is going on. These are doable problems. Remember that the place that I always start when I do these is when I have a volume of that particular concentration.